Most of us treat the moon as a scenic nightlight or a celestial clock charting out the months. It hangs up there, quiet and detached. But that quiet rock is actually a massive gravitational engine, locked in a 4.5 billion-year tug-of-war with Earth. It dictates our oceans, our weather, and even the physical shape of the planet. If it vanished this exact second, no one would notice, at least not immediately. Gravity travels at the speed of light. Because the moon sits about 384,000 kilometers away, its gravitational field would take exactly 1.28 seconds to collapse across that distance. For that brief, silent window, humanity would exist in a phantom equilibrium. The cascade of planetary disasters begins entirely in the invisible realm of physics, a full second before anyone looks up to see a blank patch of sky. Earth doesn't orbit the sun in a perfectly smooth line. Our planet and the moon rotate around a shared center of mass, called a barycenter. This pivot point sits roughly 4,600 kilometers deep inside Earth's mantle, causing our planet to constantly wobble as it travels along its orbital path. The instant lunar gravity disappears, that 27-day wobble abruptly stops. Earth's center of mass becomes the sole orbital focus, and the planet snaps into a rigid, single-body trajectory around the sun. This sudden release of stored gravitational energy hits the solid ground itself. The moon's pole currently stretches Earth's crust upward by about 50 centimeters. Without that tension, the rock elastically rebounds down to a mere 15-centimeter solar bulge. As the continental plates slam back into a solar-only stress regime, thousands of mid-magnitude earthquakes trigger simultaneously along major fault lines like the San Andreas and the Ring of Fire. Before the oceans even have time to react, the bedrock of our continents ripples and cracks, revealing that solid ground is only stable because the moon pulls it taut. Within 24 to 48 hours, the massive gravitational water bulges previously held in place by the moon collapse. Water sloshes violently across global basins until it settles into a deeply muted, static 12-hour cycle, driven entirely by the sun. This chart outlines the resulting tidal dynamics, showing that without the moon, average high tide heights permanently drop by 60 to 70% worldwide. This permanent drop in water level instantly paralyzes maritime trade. The shipping channels of London, Rotterdam, and Shanghai rely entirely on high lunar tides to clear the massive holes of ultra-large cargo vessels. Now, those channels are simply too shallow. Container ships and oil tankers run aground globally, requiring hundreds of billions of dollars in continuous emergency dredging to prevent international supply chains from freezing completely. Our entire modern shipping infrastructure operates under the blind assumption that a distant rock will continuously pull billions of tons of water precisely where needed. Above the stranded ports, the sky goes completely dark. Nighttime illumination drops by 99.9%, leaving nocturnal visual predators, like owls and wildcats, unable to hunt, while smell and sound-oriented foragers take over. Beneath the surface, this biological blackout halts coral reef reproduction. The Great Barrier Reef relies on the intensity of full moonlight in late spring to synchronize mass broadcast spawning. Without that light cue, uncoordinated fertilization fails, dooming ecosystems that support a quarter of all marine life. The darkness also breaks celestial navigation. Sea turtle hatchlings naturally orient toward the ocean by seeking the bright horizon created by moonlight reflecting off the waves. Deprived of that beacon, millions of hatchlings turn the wrong way, wandering inland to die in the dunes. Millions of years of evolution have hardwired the moon's light and gravity into the DNA of Earth's flora and fauna, making its absence an immediate ecological catastrophe. Fast forward several decades, and the damage scales up to the global climate. The moon's gravity usually provides about 1.5 terawatts of kinetic energy, driving deep ocean tides that crash against underwater mountains and mix the seas. Without this tidal mixing, critical systems like the Atlantic meridional overturning circulation begin to stall. Cold, dense abyssal water becomes entirely stagnant at the bottom, while the upper layers trap all the incoming solar heat. This breaks the mechanism that transports ocean heat from the tropics to the poles. Northern Europe plunges into a deep freeze, while surface temperatures at the equator rapidly boil up to 95 degrees Fahrenheit. That massive, unbroken reservoir of tropical heat acts as rocket fuel for the atmosphere, generating violent superhurricanes with sustained winds exceeding 220 miles per hour. The moon's constant churning keeps our oceans breathing and our weather manageable. Without it, Earth's climate engine chokes on its own trapped heat. 10,000 years post-disappearance, the planet reaches its most chaotic baseline yet. We finally witness the loss of the moon's most vital long-term function, acting as a gravitational kickstand for the entire planet. Earth's axis sits at a highly predictable tilt of about 23.4 degrees, a metric called obliquity. Right now, the moon's sheer mass exerts a gravitational torque that locks this angle in place. When that anchor vanishes, the resonance lock breaks. Over millennia, the poles of Jupiter and the Sun cause Earth's axis to wobble chaotically, swinging from 0 to 85 degrees. At a severe 80-degree tilt, the planet practically rolls on its side. The poles suddenly receive more direct annual solar radiation than the equator, triggering erratic glaciations, scorching polar summers, and the total destruction of recognizable climate zones. Maintaining a predictable, habitable climate over deep time requires a massive stabilizing satellite to hold the planet steady. A moonless Earth is a planet of stagnant oceans, lethal hurricanes, and extreme, chaotic seasons, a stark contrast to the stable, rhythmic world we actually inhabit. We tend to view Earth as a solitary haven, charting its own course through space. But our biology, our oceans, and the very ground beneath our feet rely on a silent partner. We survive and thrive because we are half of a delicate two-body life support system.